Okay, we have a rectangle of length L, width W. If length is increased by 1%, then the new length equals what? Well, it's the old length plus 1% of the old length, abbreviating length, which equals L, the old length, plus 1% of L, and of course 1% of L is 0.01 L, and this can be simplified. We factor L out. We have L multiplied by 1 plus 1.01, I'm sorry, getting ahead of myself, plus 0.01, okay, and we know that this factoring is correct because anytime we factor, we check ourselves. We multiply L by 1 plus 0.01. L times 1 is L, and L times 0.01 is 0.01 L. So this gives us this, and factoring is just using the distributive law backwards, so that works. And of course then, that equals 1.01 L. Now, if we, and actually in the problem as stated, the length was increased not by 1%, but by 2%. So what would change if the length was increased by 2%? Well, there's the answer. I'm not going to comment on it. You understand what I did? Okay, now, if we also increase the width by 1%, we get, and 1% is right for the width. The new width will be 1.01 W. Yeah, put parentheses around that just so we know where the words stop and the numbers start. Okay, that's good. Now the question is, what's the expression for the new area? Well, new area is going to be the new length times the new width. I'm not going to write that down. I'm just going to write the expressions down. The 1.02 L multiplied by the 1.01 W. And of course, we can multiply that out. Now you take your calculator and multiply it out, but you really shouldn't. You should remind yourself what all this means. And but you know, I didn't say not to. Simply saying that if we express that 1.02 as 1 plus 0.02 and the 1.01 as 1 plus 0.01, times the product LW, we can expand this and get kind of an interesting result. Okay, so 1 times 1 plus 0.01 is 1 times 1, which is 1, plus 1 times 0.01, which is 0.01, plus 0.02 times 1 plus 0.01, that's 0.02 times 1. Incidentally, if you're thinking FOIL, please stop. Never think FOIL again. 0.02 times 0.0, it's distributive law. 1 times all this is 1 times this plus 1 times this. 2 times this quantity is 0.02. 0.02 times 1 plus 0.02 times 0.01. You don't need a silly acronym to do that or to understand the distributive law or factoring. Okay, well, we do that, and we get 0.01 here. Now I wrote just 0.01 because 1 times 0.01 is 0.01. I wrote the times 1 here, and to be consistent, I'm just going to remove that. Okay, got a little gap there, but we can live with that. We get 1 plus 0.03 plus 0.0002. Okay, and that's, of course, 1.0302. Now this line has been magically rewritten. I got all excited about the details of expanding this product of binomials and neglected to write down my LW. So got that here. I've got it here. Excuse me. Okay, so this is, of course, 1.0302 LW. And I guess I can write that out. 1.0302 LW. And that's very close to just plain old 1.03 LW. Now let me get out of the way and show you what I've written. Okay, no surprise there. This O2 here only represents less than 1% of the difference between this number and 1. It's really pretty insignificant. So I'm going to say that what we get is approximately very close to just plain old 1.03 LW. Now the original area was LW, so we conclude that the area increased, if we want to be precise, by 3.02%. And I've written out what the increase. The area increased by 3.02% because 1.0302 is 3.02% more than 1. So increased by 3.02%, which is very near 3%. That 0.02 doesn't amount to much. So what we can say is that increasing the length by 2%, increasing the width by 1%, increases the area by about 3%. So we can make the statement that a 2% change in L and a 1% change in W results in a 1% plus 2% equals 3% change in LW. Okay, and why would I add 1% to 2% to get 3%? Well, because that's fairly obvious in terms of the numbers, but we can actually justify that if we go back here and see where the 0.02 came from, or at least what happened to the 0.02 is multiplied by the 1 to give us a 0.02. The 0.01 was multiplied by this 1 to give us a 0.01. So when those were added together, we got the 0.03, which represents a 3% increase. Now we also had 0.02 times 0.01. Since both of these are small numbers, their product is a really small number, as you should understand if you understand what multiplication really means. Okay, so this number becomes pretty much disposable. So within a good approximation, if we're having a small percent change in two numbers, to get the change in their product, we just add those 2%. So the same thing would happen if we had different percents here. As long as the 2% are small, then this number here is going to be small, and this number here will in any case be the sum of those 2% expressed as proportions. So I'll say to get percent change in a product of two numbers due to small percent changes in those numbers, just add the percents. Okay, or maybe I should say add the percent changes. Okay, I said it that way. Now I could write that more precisely because this is a little bit vague. It's not in precise mathematical terms, but if I write it out precisely, the tendency is going to be for you to memorize it as a formula instead of understanding what it says. If you understand how this calculation gives you the 0.01 and the 0.02, you'll understand how these two small percent changes will give you a similar result, resulting in the sum of those 2% as the change in your original quantity, in the product of the two small quantities. Now, if we were educating people in Algebra 2 courses, for example, even Algebra 1 courses, instead of teaching them tricks to beat the SOL without understanding any of the mathematics, and again, please understand that I know why your teachers have to do that. It's a top-down dictate, and they can't do much about it. They've got to get a lot of people through. But you would already be thinking along the lines of something like this. Okay, I'll just suggest that you should think about why, if you multiply 1 plus a times 1 plus b, your answer is close to 1 plus a plus b, provided a and b are both small, which could be indicated both much less than 1, much less being indicated by two consecutive less than signs. This sort of reasoning becomes important in properly taught calculus courses and beyond. So, and in applications to physics and other sciences that have mathematical basis. It's a very important idea, so it's worth thinking about. There's a geometric connection to go along with the algebraic connection. Going back to our original rectangle, it's length L, width W, and we then increase the length to 1.02 L and 1.01 W. Now, 1% of the width is, a lot smaller than what I've indicated up here, and a 2% of the length is a lot smaller than what I've indicated here. But you understand that I couldn't draw them with chalk and show just a 1% change. Now, what's the difference between the area of the bigger rectangle and the area of the smaller rectangle? Well, the difference is, it's going to be the area of this portion. Okay, that area is going to get added. And then you have another portion here and another portion up in the corner. And I'm going to shade those off camera for sake of time. Okay, I've shaded this added portion of the area, the portion that runs along the whole width of the original rectangle, purple, and the little corner up here that's just got dimensions 2% of the length by 1% of the width in red. Now, why would I have done that? Well, you should stop right now and get the expression for the area of this region, the area of this region, and the area of this region. Okay, well, you should have started by just figuring out what the dimensions of this slim region are. Well, here's W, and here's 1.01 W. The difference is 0.01 W, so the width of this strip has to be 0.01 W, and it runs for the full length of the original rectangle, so it's L by 0.01 W, which is 0.01 LW. Similar reasoning tells you that the purple strip here has dimensions 0.02 L by W, therefore area 0.02 LW. Now, what do you think the area is of the smallest region? Okay, hope you paused and thought that through, but its dimensions are, we got 0.02 L here, the difference between L and 1.02 L, and we have 0.01 W up here, so dimensions are 0.01 W by 0.02 L, which gives us 0.0002 times LW. Can you see the connections with this calculation or this calculation? And can you see geometrically how the result is a 3% change in the area?